From me to the cabinet.
Hey, students, if you're paying attention, say hi to me, please. I want my ego to be validated. Oh, mine.
Yes, this is Mr. Sprunger.
Hello?
He teaches junior and senior level theology, if you haven't met him yet.
A few of them I think I've met in study hall.
All right, so let's see. We've got Johan here, and we've got... Wait, don't tell me. No, Alondra? Yes! First try. Okay. And then we've got Vanessa online, Yasmin's online, Regina's online, Brian's online, Wendy's online, just missing Leslie. Okay. Right. Well, let's get started because we've got a lot to do. And we happened to stumble upon a very relevant quote today. And I've randomized these things. But since we're dealing with logical arguments and finding and sorting out truth, it's interesting that our quote highlights that. So, speaking of, if you're worried about finding the truth, then what you need is a valid argument. And actually, you need a little bit more than that. We'll get to that in a moment. But we're going to take a look at very specifically what it takes to form a valid argument. What is good reasoning? And good is not quite good enough. We have more specific terms. In fact, most of today is going to be about defining more specific terms for some of the things we've already been doing. So we're going to still use yesterday's Sherlock Holmes material and the readings from your homework from last week, that Sherlock Holmes adventure. And we're going to give specific definitions to all these terms. So please take out your notes, either digitally or on hard copy. It doesn't have to be Cornell style, but I want you to write down these definitions so you've got them all in one place for reference later. The first thing we're going to define then is logical argument. You might think it's obvious. We've been using them this whole time. But we're going to say that is any set of text or speech that consists of a set of premises and a conclusion. Now, of course, what are premises and a conclusion? Well, all of the given statements, all of the starting points are premises. These are things that you have already established. You already agreed upon them. And the statement arrived at through reasoning is called a conclusion. So the statement that you're ending with, the final thing that you're trying to get to, is your conclusion. So for example, the statement, if it is raining, then the ground is wet, that's one premise. Right? We already accept that. And like, yeah, okay, that makes sense. In general, that's the case. Second premise, it is raining. Right? That's just an observation. You can look outside and decide yes or no. And then third would be the conclusion, the ground is wet. Right? You can't test that just from looking out the window. You'd have to go and you'd have to like step on the grass or poke at it or something to really know for sure. Or you could rely on your logical reasoning to put these two statements, these two premises, that's why I have the P after them for premise, together to get this conclusion. And all together, the three of them form a logical argument. Now, this is the smallest form of logical argument. You could, of course, chain multiple ones together. And so from this conclusion of the ground is wet, that could become the premise of a new argument. Say, well, if the ground is wet, then the plants will grow or something like that, right? You could chain them together and go on from there and develop new conclusions and form a much bigger argument. Now, how do we know if this argument is any good? Well, good is a little bit ambiguous, right? And so we're going to focus on two specific traits: validity and soundness. A valid argument is one that the conclusion has been arrived at through accepted forms of reasoning. That is to say, you used the rules of logic properly. It adheres to the correct structure. Okay? So in my valid versus sound, I'm going to say valid has to do with the structure. Didn't give myself enough room. It uses the rules of logic correctly. Right? That's all it says. It does not say anything about whether something is true or false. Okay? So take a look at my sample argument again. If it is raining, then the ground is wet. That's a general case. That's going to always be true. But my second premise, it is raining. It's awfully sunny outside. I'd say the second premise, today, is false. Which means my conclusion, the ground is wet, is also false. It is not wet right now. I mean, maybe damp because it was raining recently, but certainly not wet like it is when it's raining, right? However, because I still set it up in the proper structure, this argument is valid, even though my conclusion is false, okay? That is still acceptable. So, if you want to get into an argument with someone, and you want to try to call them out on their BS because they have some bogus conclusion, no way, dude, you're wrong, make sure you're calling them out on the right thing. Their argument could be perfectly structured, but they started with a false premise. That's why they have the wrong conclusion. So their argument is not valid. Doesn't say anything about true or false. In fact, be very careful. Only the statements themselves can be true or false. A whole argument is not true or false. A whole argument, right, the group of statements is valid or invalid, sound or unsound. Now let's get to sound. That does deal with truth. So valid is dealing with the structure, sound deals with the truth. In order for an argument to be sound, all premises must be true. This means my example argument about it raining, it is not raining. This is a false premise, therefore this argument is unsound. It's valid, but not sound, because at least one of the premises was false. And as they point out here, you can read this example on your own. If you have a false premise, you can effectively conclude anything you like, and it's garbage in, garbage out, right? It's not going to make any sense. So in order for an argument to be considered good, it should be valid and sound. That is an argument that you can't argue against the argument. Yeah. Can't refute, that's a better term, thank you. All right, any questions on valid versus sound? No? Okay. Then the next step. Next term is conditional statement. A conditional statement is any statement in this form. If something, then something else. If P, then Q. We, being mathematicians, are extremely lazy, and anytime we can get away with writing less, we will. Therefore, the other thing we're introducing here is the fact that instead of entire sentences, we might just put one letter. So the capital P and the capital Q are standing in for, in this case, Watson had chalk between his fingers, and Q stands for Watson was playing billiards, back from the Sherlock Holmes story. Right? Because we're going to end up writing this stuff a lot. Okay? You write your own logical argument. You might have to write the same sentence, the same statement, like 5 times. You don't want to write it all out 5 times. We're going to shorten it to one letter. Or as long as you define a key and say up front, hey, P stands for this, Q stands for that, you can just use P and Q as you go. And for whatever reason, historically, logic got assigned letters P's and Q's, just like when you're graphing in algebra, you use X's and Y's. That's just what they picked. All right, so here we go. Conditional statement, if P, then Q. We've been using them. And the way we were using them yesterday, we're looking at the law of logic called modus ponens. Right? Modus ponens. Fun to say. That pop. I don't know. It's Latin. It's a little goofy sounding. Just the same thing we were doing yesterday. It is combining a conditional statement, if P then Q. That first half, the ponens.
Mr. Apple, I can't hear you. I don't know if I'm the only one. I don't know. I already tried turning my volume up.
I think it's muted.
Yeah, I think his audio just doesn't work because it doesn't show that he's muted.
Yes.
Yeah, I can hear you.
All right, switching to the webcam microphone. That did not last long at all. That was, let's see, I used it last week. 1, 2, 3, 4, 5 days.
I suppose, what, like, roughly
All right.
6 hours a day. 30.
Decent, yeah. All right. What a shame. Okay. I better get closer here then.
What is it? Is it double A's?
Yeah, it's just a couple of days.
I'm trying to see if I can find something.
Yeah, sure. Yeah. That'd be great. Thanks.
I don't want to.
Yeah. All right. Since you may have missed some of it, questions on modus ponens? No? And let's carry on. Next up, very common practice. Now we've got a fancy math term for it. The negation of a sentence is when you put the word not in it. We do this all the time, right? It is not the case. You could say Paula will receive her inheritance, or you could say Paula will not receive her inheritance, right? It means exactly the opposite. And you could get fancy. It is not the case that Paula will receive her inheritance. Paula won't receive her inheritance. You can use a contraction, however you want to spin it. Okay? Whatever linguistic version you use, I think we all understand the concept of adding not, say no. And then if you can negate something, we can also double negate if you add not the thing. This is the how to get around the rules loophole thing. Well, did he say that you're allowed to do this? Well, he didn't not say it. He didn't not say, didn't not, right? Two negatives make a positive, just like multiplying numbers. Negative times a negative is a positive. If you say didn't not do the thing, that means yes, you did the thing. Right? Mike did not win the sweepstakes. It is not the case that Mike did not win the sweepstakes. That means Mike won the sweepstakes. Fair enough? Double negation. Again, something we use in everyday conversation, maybe on purpose, maybe on accident, but we're going to be very particular here. And notice even when I shorten this, if I shorten Paula will receive her inheritance to P, to say Paula will not receive her inheritance, I want to write not P. Don't hide the negation inside the letter. Put that out front. Know that one negation is present so that you don't accidentally double negate when you didn't mean to. Right? Now, how is all of this useful? Well, it turns out, with the power of negation, we have another law of logic. We have modus tollens. This is modus ponens' brother, or cousin, if you will. And it works backwards from modus ponens. Modus tollens inverts the conditional while we are negating it. So here is the structure for modus tollens. We still have the conditional statement, in this case using S and T. If S, then T. But instead of stating S, we're going to state not T. Right? So we're going to restate the end of the conditional instead of the beginning, but we have to negate it. And then we can conclude the negation of the beginning. All right, so for example, here we have Holmes's final deduction was, if Watson wished to invest his money in South African securities with Thurston, then he would have had his checkbook with him when playing billiards with Thurston. That makes sense. If you want to buy something, you better bring your wallet, right? Watson did not have his checkbook with him when he went to play billiards with Thurston. Therefore, Watson did not wish to invest his money in South African securities with Thurston. To put more simply, in a modern example, if you wanted to go buy something, then you would have brought your wallet with you. But I've just observed you did not bring your wallet. Therefore, you must have not actually wanted to go buy something. Right? Because you couldn't have done it. So it reverses the conditional as long as we put the negations. Okay? I've circled the knots on both of those. It is absolutely critical that you negate both of them. just negating one of them is not a valid argument. Back to our raining example. I did not get wet when I went outside. If it is raining, then I would get wet when I go outside. Therefore, it's not raining. That's a valid argument. It's also a sound one. Makes common sense to us, like, well, yeah, okay, if I go outside and I don't get wet, it couldn't possibly be raining, because the rain would have made me wet. That's what it does. So here we have not W, if R then W. Notice the single statement matches the end of the conditional, and the conclusion matches the beginning, but they both have the negation. And yes, you can freely swap the order of those. The order in which you make these statements doesn't matter. I usually like to start with the conditional, but that one works okay. Questions on modus tollens? This is the trickiest one to use. Okay? About half of our practice today will be identifying which one it is. Is this an example of modus ponens or modus tollens, or perhaps neither? Okay? Hey, there we go. Extra batteries. All right, then if there's no questions there, the final thing will be, for you visual people, we can use the Venn diagrams here, or since there's no actual like half-lapping of them, they're more properly Euler diagrams, but it's a minor thing. Take a look at the first diagram there. If P, then Q. In this case, P stands for the animal is a dog, and Q stands for the animal is a mammal. We know from biology, right, all dogs are mammals. So if Spot is a dog, then he must also be a mammal. There is no way to not be a mammal. So the circle of dogs, right here, is entirely inside the circle of mammals. Right? But we know that there are mammals that are not dogs, right? So they're not in the exact same circle. You could have one without the other. And I'm having a terrible time trying to get this darn battery out. Here, see what you can make of that. There's not quite enough room for me to grab it. Okay, so this is an example of if P, then Q. Because that statement, if P is true, Q must follow. If you are in circle P, you also have to be in circle Q. I know, right? This is not quite enough room for your fingers. I like to also think of this as a map. Okay? Visually speaking, if you are in the city of Chicago, then you must also be in Illinois. Right? But you could live somewhere else in Illinois that's not Chicago. Right? So if you live in Chicago, then you live in Illinois, guaranteed. Now, compare that to if P, then not Q. If Spot is a dog, then he is not a fish. Agreed? There are no dogs that are also fishes. They are two totally separate things, so they are two totally separate circles. One. Hooray! Oh, there you go, using tools. Brilliant. All right, just in time for class to be pretty much over. Oh, he's done. Yep. Okay. Any questions on Euler diagrams? Or Venn diagrams? Oh, that one was still blinking. It's still on.
Oh, yes. Don't you have two?
Transmitter, receiver.
Oh. I meant that you switch the input back on the thing.
Oh, on this, data. Okay, hearing none. Then, hey, that's working there. Go ahead and start working on the exercises. Can you hear me now?
Yeah.
Excellent. All right. Switch successful. All right, you only have to do the odd exercises here. 1, 3, 5, 7, so on. Just the odd numbers. The first section, translating from symbols to statements. So here they give you the setup. Your job is to rewrite these exactly as they are, except replace the single capital letters with their corresponding statement. You're still going to write the ifs. You're still going to write the nots. Okay? Number 4, you want to write if not, but instead of are, you write I will go to the movies. If not, I will go to the movies. That doesn't quite sound right. Move the not wherever it belongs to make the grammar sound better. If I will not go to the movies. Right. Okay? That's all you're doing there. Second section. Same but opposite. They give you the full version with all of the words. You're going to reduce it to just the single letters. If today is Wednesday, you write if P. Right? Practice the shorthand. All right. Third section, drawing a Venn diagram for the given conditional statement. And next section, the opposite. For the given Venn diagram, write a conditional statement. You only have to use the letters, okay? If R, then Q, or if S, then R, or whatever it would be. You do not need to translate those letters back into full sentences. And then finally, the last section is the most involved. This is where you will be making that judgment call. Is this a valid argument? Does it fit one of those forms? So let's go through 15 as an example and have a look. If Sherlock Holmes gathers all the clues, then he will be victorious. Sherlock Holmes gathers all the clues. Is that a valid argument? Well, the first thing I would actually ask is, did I repeat myself at any point? When I read that, did I say the same thing twice? Yes, absolutely. Okay, good. If I didn't, we could stop right there and say, no repetition, these statements have nothing to do with each other, no valid conclusion. But I did repeat. I repeated, Sherlock Holmes gathers all the clues. Which part of the conditional did that repeat? Was that the first half, the condition part, or the second half, the concluding part? The first half, yeah. Now, did I repeat it exactly, or did I add a negation? Exactly. Therefore, this is an example of modus ponens. Modus ponens has you repeat the beginning of the conditional exactly as written, no negations added. And that allows me to conclude the conclusion of the conditional, the ending, second half, exactly as written, no negations added. So then what we're going to do is we're going to translate these into letters and write out our full modus ponens argument. So I'm going to say, let's say this part gathers all the clues. Let's call that C for clues. And he will be victorious. Let's call that statement V for victorious. All right? You can do this too. Just underline which sections, give them a letter. And now we're going to write our argument. The first statement was if C, then V. Second statement, C. Right? The sentence, second sentence there. Just repeating that exactly as is. So 3. Therefore, we conclude V. That's it. That's our whole argument. Now there was one final piece, just a moment. They want us to go ahead and write out the conclusion in word form. So we'll translate this back to full English. Therefore, he will be victorious. There we go. That's what you'll do for each of these. Okay? Questions? Gosh darn it. Who put that there? Who decided this? It must be the French. They love sticking extra silent letters on things. See, this is why I'm a math teacher. It's okay. Tomorrow we will learn a symbol for therefore, and we'll never have to write that word again. See? Sneaky, sneaky. Avoiding spelling whenever possible. All right. Any other questions? Explain it. Everything I have written is what you will need to write for one of those. Of course, if it is modus ponens, right? If it's a modus tollens, you would structure it as the modus tollens one. But identify which one it is, if any. There in the directions they say if it's if they do not fit either pattern, write no valid conclusion, and you're done. But if they do, you're going to state the conclusion in English. Done that here. Translate the complete argument into symbolic form. That's this part. And part of that translation is identifying which statements go to which letter. The easiest way to do that is just underline and put a letter over it. Or highlight, or box, or circle, wherever you want to call that out. All right. Other questions? Sure. Yeah, if you're writing this separately, then you'll have to rewrite at least each statement to identify which letter you're assigning it. Otherwise, then, you've got 10, 11 minutes, 12 minutes to work. I'll leave you to it. All right, Mr. Sprunger, any questions? What about the thief on the cross?
As soon as he's done. That's cool. Therefore symbol.
That's tomorrow's lesson. I don't want to spoil it.
It's funny, like, in, like, I guess, like, Bible lesson to do. This is basically if-then, quite prescriptive, I guess. If the statements don't fit, then don't do this. Like,
Oh, yeah, it's,
that's why I noticed that. I was like, wow, it's so better.
well, I noticed that myself about the valid, right?
Yeah. Actually, I do
Like in trying to describe, you have to use modus ponens to state if your argument follows the rules of logic, then it is valid. It's like, well, that itself is a logical argument. You have to use a logical argument to explain that it's logical. Yep.
Is there a term for an argument that's both sound and valid? Did I miss that? Or like, is there a term that you just didn't go right? I feel like I thought there is. Maybe it just
I don't recall one. We don't have, there might be a single unifying term. I said that makes it good. Because that's,
Good or logical.
yeah. I don't know if we have a specific one.
So valid is logic itself is fine, and sound is
Yeah, but not everything. The premises are true. Right? The conclusion could be false in a sound argument because it's actually not a valid, but if that's the case, it would be a non-valid argument. That's the only way to get a
so like
false conclusion.
an invalid sound argument would be if I drove to work today. Or if I drive to work today, I'm wearing a red shirt, therefore sound. No, that'd be sound but not valid.
Could be sound if the premises are true. Yeah.
But being contrapositive is more. That's what it's called by the word.
I do, but that's because I agree with the premises.
Well, okay, do you think?
Right? So just like, so yeah, it would be, it's certainly a valid structure. And so the question of whether or not the conclusion is true comes down to soundness. Are the premises true? And that's really, if any disagreement on such things, that's what it all comes down to, is people are actually disagreeing with premises that may or may not be stated. Right? A lot of these arguments are frequently begging the question that they're making assumptions that haven't been brought to light.
I don't hear a ton about like how oral argument is debated. I haven't seen as much about that, but there's one of the cosmological slash first cause argument. Thing that begins to exist as a cause, the universe began. Obviously, that's not God right away. From that, then, but yeah, those why that the law of causality is true, and then like tells that the universe did actually have a beginning, and then
Right, exactly. And it comes down to, do you accept that premise that everything that happened had to have a cause? You say, well, no, the universe didn't. Well, then it wasn't everything. Right?
happened, but begin.
Or everything that begins to exist had a cause. Right, and so if you disagree that the universe had to have a cause, well, then you are actually disagreeing with that premise, saying not everything. There's one major exception. Oh, yeah. I know, right? But if you get thirsty and you don't have a water bottle. All right, I really want to try setting up this thief on the cross, though, right? Because the conditional would be something like.
Well, are we doing the argument for like the skeptical question bringing it up, or are we arguing for the?
If you are baptized, then you are saved. Right? That is the premise from that they're usually trying to refute with, what about the thief on the cross? Right? It's an argument against salvation from baptism. But it doesn't follow. Right? You can say, the thief on the cross was not baptized. And the thief on the cross was saved. So the question is, how do they contradict this statement? And the answer is they don't. Because if you are baptized, then you are saved, says nothing about being not baptized, right? Thief on the cross is an example of, see, that would be the statement, if not baptized. Stupid, if I write too fast, it starts to merge them together. Then saved. Those two are not the same statements, but they are not necessarily contradictory either. And the thing we'll get to next week will be the actual contrapositive of a conditional statement. And so that would be reversing it.
How is that different than what you did?
So this is if baptized, then saved. The contrapositive would be if not saved, then not baptized.
How is what you're going to do next week different than what was told?
So modus tollens would be using the process of modus ponens on the contrapositive of the conditional statement. So it's more of a shortcut, as it were.
What are you going to do?
Because there's you can take a conditional statement and different ways to alter it, and you get the inverse or the converse or the contrapositive, right? And only the contrapositive is still logically consistent with the original. That's what I have here, right? Both of these, if this one is true, then this one is true. They both mean the same thing. And so modus tollens is saying, okay, take that statement, contrapositive, and now run modus ponens given the not s. And so that's why it sometimes is called the law of contrapositive, because it uses the contrapositive.
So what are you going to do?
We'll talk about inverses and converses and contrapositive, all those. Yep.
Okay.
Yep, all those bits. Yeah, so this then is separate argument that doesn't contradict these necessarily. Like, it doesn't prove that this is false. Right? And that's what people a lot of times try to do. They say, oh, but because of the thief of the cross, this then is false. It's like, no.
If you want to disprove the claim, if B then N, not disprove that, you have to say it. So yeah,
You would have to show me
people that have been baptized and clear,
if B then
or at least any
not S.
Yeah,
Right.
not as a
You would need a counter example. So someone who has been baptized that isn't saved. Yeah, but what you're talking about is someone who was baptized in the past and now, after later actions in their life, is no longer saved.
Right.
Right? What you need is an instance of baptism not applying the salvation. Right? At that moment.
Yeah. But isn't that, I mean, like when we say baptism, aren't we ultimately making that kind of longer claim? Not just, we're not really concerned about the instant unless somebody's like baptized like
Well, true. And that goes with our understanding of salvation being once saved, always saved, unless you choose to fall away, right? Yeah, so it's not
which is pretty big unless.
it's a bad definition of always. But anyways, it is 2:30. You are dismissed. So long. Farewell. Enjoy the rest of your day.